So thank you all for coming. My name is Miroslav. I come from Bosnia and Herzegovina. Hope you know where it is. It's a part of ex-Yugoslavia. At the moment, I am working for a company named Sivus, which is a Swedish Macedonian company. And we have a client here in Amsterdam, which is Tele2. So I'm here for client work. And I just asked Eric, while I'm here for the first time in Amsterdam, can I join and have a talk on a meetup? So here I am. Okay, so what we are going to talk about this night. Building production-ready APIs with ASP.NET Core 2.2. It's kind of a mouthful title. But okay. So let's first try to define some terms that we will use during the presentation. First, let's talk about REST. So these APIs that we are going to talk about are RESTful APIs. So REST is a type of architecture that's using the existing web infrastructure. So it's using URLs as unique identifiers for each resource. It uses HTTP verbs like get, post, put, delete, batch. And when a service implements REST, we say that it's RESTful. So also REST APIs are the data in the form of some data format. The most important ones or most used ones are JSON and XML. By default, ASP.NET Core is actually using JSON, or it's more prevalent, but you can also enable XML format and use that. So it's used for either the input data or the output or response from your APIs. Okay, so when you start looking into REST and do a Google search, you'll see that one of the differences, one of different opinions on REST is we have two views, strict and pragmatic view. So strict view is telling you that you must do whatever it's stated in REST documentation. And pragmatic approach is more like more relaxed. So try to follow REST as close as possible, but if you need to, I don't know, have some URL that doesn't look very RESty, so you can just I don't know, use something that looks like a remote procedure call or something like that. Okay, so another main player of our talk is ASP.NET Core. I'm sure most of you are familiar with it. So it's an open source framework built by Microsoft, built from scratch. It looks like the previous ASP.NET full framework that's now kind of not developed anymore. So it has the same API, but it has some new things. It's cross-platform. It has hugely improved performance over the old ASP.NET. And actually, the point that it's open source helped with the performance perspective, since most of the pull requests and commits that change, that improve the performance of ASP.NET Core framework were actually committed by the community, not the guys from Microsoft. So at the moment we have round 16 of Tech Empower benchmark that came out a day or two ago. And in that, I think ASP.NET Core is in top 10 again of plain text response. So it's, I'm not sure how many actually frameworks are there. I think about 100 or so. Most of the top 10 frameworks at the moment are some academic frameworks, not used for production. But ASP.NET Core is one of few of them in top 10 that is actually production-ready framework. So also in this round of Tech Empower benchmark, it's number 6 for Fortunes test. Fortunes is more real life like test. So it tests everything, not just plain text response. It tests JSON, output, data access, and stuff like that. Okay, so as I mentioned, those performance are far improved by comparing it with the old framework, and that is one of the benefits that you have if you are currently on the ASP.NET and you want to move to something better or newer. Also, it has dependency injection built in from the start. So everything is replaceable in it. You can just use whichever part you want from it, take it off and replace it with some other implementation. And dependency injection is, by my opinion, one of, if not the most important software design pattern at the moment. Also, one thing that changed by comparing it with old ASP.NET is how requests and response are processed. So before we had some modules that were processing the request and response and gave response to the client. Now we have a pipeline. Pipeline is an area of middlewares that are connected. So some kind of a linked list. So one middleware, first middleware gets the request, does something with it, and just gives it to another middleware, and they form a chain. And when the request comes to the last middleware, which is in most cases MVC middleware, which is the biggest one, it returns the response back through all of the middlewares, but in reverse order. So each middleware has a chance to either do something with request or with response. And this model is pretty easy to grasp. It's not hard as we had before. Also, we have action filters. Action filters are actually part of MVC middleware. So those are the things or components that you can define on controllers or your action methods on controllers. And you can do something with the request or with the response. What else? Routing. We said before that REST APIs define resources via unique URLs. So ASP.NET Core routing helps with that. We have two different ways to define routing, either through conventions or through attributes. Convention-based routing is not really used for APIs. It's more used in MVC pattern for views. But attribute routing is more API thing. So in the latest version of ASP.NET Core, this also changed and moved down a bit. It was more entangled with MVC middleware before, and now it moved a step down, and it can be used from other middlewares, like from SignalR or something. Also, what else do we have? Content negotiation. Content negotiation is actually a way to have different outputs based on the user input. So as a client, you can ask for either JSON, XML, or some other format, and the web API will just return you that, or ASP.NET Core will return you that. So you don't, as a developer, you don't need to define or program different formats. You just define that in your startup class, and it, based on the client request, it just returns you what the client wants. Then we have configuration. Configuration is new. It's part of .NET Core. And it replaces the old web config that you had before with a lot of more granular pattern. So you can have environment-specific configuration, like by default you can have app settings file for each environment you have, for development, for staging, for production. You can have settings defined in environment variables, in user secrets, which is kind of a way to avoid stuffing all of your important things away from source control and from app settings, and leave that on your machine. So do not commit the things that are security sensitive. Then we have logging. For logging, we have infrastructure, and by default, we have logging to console and to debug. So if you attach a debugger to a running application, you'll just get logging responses from that. You can inject any kind of log output you want, or you can use some existing logging framework like CanLog, Log4net, Serilog, or something like that. All of them have support for .NET Core. Okay, so ASP.NET Core 2.1, it came out this year, I believe. One important thing that they were stating is the first line. So making MVC into an opinionated, forward-thinking, batteries-included framework for HTTP APIs. So they were committed to make this the best possible platform for APIs, for REST APIs. And some new things came with this version, like HTTPS by default. So before we had to include this manually or add it to a startup. Now it's by default in. And of course, since we are talking about APIs, you always should use HTTPS, and not just for APIs, for all kind of web applications. Since SSL and certificates are rather cheap these days, or free, like for Let's Encrypt. Another new thing are API controllers. API controller is actually an attribute that you can add on top of your controller. I don't know how many of you have worked with the old ASP.NET version. When ASP.NET Web API was introduced, you had two different stacks, basically. So all the ASP.NET MVC had controller-based class. ASP.NET Web API had API controller-based class. Then you would inherit from that and add some action methods. Now we have a unified platform for that, for any kind of either Web API or MVC. And with this attribute, you actually tell ASP.NET Core that you want that this controller is actually an API controller, which triggers some conventions. And we'll see later in demo what those conventions are. Then we have action result of T. This is a generic class. So before ASP.NET Core 2.1, we had only iAction result, which is an interface. Why this was introduced? Because it helps with generating Swagger metadata, and you'll see how that's done later. And another thing which is more low level is that Kestrel, which is a web platform that, or web, how do you call it? Web server, yeah. That's web server that comes integrated in ASP.NET Core, and it's not yet production ready. It's close. You need to use some kind of reverse proxy on top of it. But Kestrel got support for sockets, and that also helped with the performance. Okay, so this is the link where you can find more about this version. And the current version is ASP.NET Core 2.2, which is at the moment in preview 3. I think this will be last preview. I'm not sure will there be RC version. For Entity Framework Core, there will be no RC. They will just go to RTM, and that should happen before end of this year. So these are the new things in 2.2. We have improvements on API conventions. You'll see how that looks like in demo. There are API analyzers, which are using Roslyn to actually, when you have this API controller attribute on the controller and you write your action methods, Roslyn actually checks using this API analyzer whether you are adhering to those conventions. So are you returning the correct types and the types that are expected in a response. Then another new thing is HTTP2 support for Kestrel. Again, a low-level thing, but helps us with performance again. We also have health checks. Health checks are kind of a new thing, and they are actually usable when you have microservices. And you know how, let's say, Twitter or GitHub have status dashboard, where you can check what's the status of their platform. So each service they have, it might be green, it might be red if it fall down or something like that. So we have support for that now in ASPNET Core 2.2, and you'll see how that works. Then this new thing that I mentioned earlier, called endpoint routing. Endpoint routing is just moving the routing part to lower level, so other frameworks may use it. Another new thing is HTTP REPL, which is kind of usable. You'll see that in demo 2. And this is a link where you can find more about the new features. Okay, so what do I mean when I say production ready? First, when you start with an empty project, ASP.NET Core, you'll probably do some things like you know that the web API can return just any object as a response, but you'll probably want to use iActionResult or ActionResult of T, because with that you can return not just that object as a response or some data, but you can also return bad request, not found, some HTTP status codes, which are helpful in building APIs. Then to use view models. So whether you call these view models, input models, binding models, or something like that, these are custom DTO classes that you use as requests and responses. So the point is not to use the classes that are, for instance, domain entity objects and that are loaded from the database and saved directly to the database, but just to have a subset of those properties and use that. Why is that important? So let's say if you have like a user endpoint, you have your application where user can change their profile image, for instance. And the user goes there, selects a new image, and clicks save, and opens web developer tools and see what the request looks like, and decides, I can just, in addition to this image, I can just add is admin true, for instance. And by chance, your domain object also have is admin true, which controls if your entity is, if your user is admin or not. And when user sends that is admin, it actually becomes admin of your application and can change anything. So this looks kind of naive, but it's actually a real case that happened, I think, in 2011 with Ruby on Rails. So Ruby on Rails is using active record pattern for object relational mapping, and they had this issue actually. So you could just use something and make yourself admin for that. So one developer found out that issue, and since Ruby on Rails is hosted on GitHub, there is a repository for Ruby on Rails on GitHub. He created pull requests, he created issue, and he notified the actual developers of Ruby on Rails that there is a problem with it. And he was ignored for a few days. And so he remembered that GitHub itself is built on Ruby on Rails. So he kind of used that, the hole, and he made himself admin of Ruby on Rails repository on GitHub. Then he merged that pull request in and applied, and of course then he bragged about it on social media and stuff like that. So don't be that guy, or be that guy, don't be Ruby on Rails team. So that's the point. Okay, so another thing connected with that, always do input validation, never trust the user, your client. Then exception handling, of course, you don't want any error that happens on your API to just give every detail to the client. You need to form that out and remove the necessary or security related things. Then you need to log things, of course, and do paging. If you have a big data set, you don't want to give everything in, like for thousands and thousands of items back to the client whenever it asks for the list of items. Just do a page of those. Okay?
This list includes that you separate your data handling in a different project?
Well, yes, you can say that.
Because of this view model?
Yeah, you can say that. Okay, so how this presentation works, I have a demo, and it has several steps defined in different branches on GitHub. So I have few slides, and then I move from slides to the one of those branches. But since it will take some time to do a switching, I'll just go through all the slides, and then we'll get back to the demo. So this is first thing, best practices. Second thing is security. So like I said before, HTTPS, I mentioned this 2.1 is actually, those things are introduced in ASP.NET Core 2.1. I'm using ASP.NET Core 2.0 as a baseline, and new things are marked with this label. So HTTPS by default in 2.1. For API authorization, we are mostly using, or almost always using, OAuth 2.0, which is a standard for authorization. And for this demo application will be using token-based authentication with JWT, or JSON Web Tokens. And also in the application, you'll see that I generate those tokens in a demo controller. So don't use that. Of course, you'll have some kind of token server or authorization server, which gets you those tokens. If you need to implement your own authentication server, authorization server, you'll use something like Identity Server 4. It's an open source framework, which is, it's an old framework that's, I don't know, it has support for old ASP.NET, but it also, Identity Server 4 has support for Core. And with it, you can just do, it has support for OAuth 2.0 and support for OpenID Connect. So those are two different things that you want to do. So OpenID Connect is for authentication, standard for authentication, and OAuth 2.0 for authorization. So you can use that. Actually, Microsoft recommends to use Identity Server 4 since there is no authorization server in Core. There was one in Web API before, but they didn't build a new version here. They were planned to build that with 2.2, but they decided not to, and instead to integrate Identity Server 4. So with 2.2, I believe, maybe in 3.0 you'll have support for Identity Server 4 out of the box, and the configuration will be really simple. like app.use identity server or something like that. If you want to use some third party, you can use Auth0 or Okta. Those are also authorization authentication servers. Okay, next thing, testing. So we all know that testing is really important. There are different ways we can test our application, either doing automated testing like unit testing, integration testing. Of course, we never do enough of those. Then you'll have manual testing. So whenever you need to quickly test something using some tools like Postman, which we'll see a bit later, and Fiddler or something like that. Then there are stress testing, load testing. There are few tools for that I found while Googling. They have pretty strange names, Loader, Artillery, and Gatling. So those are for that. And yeah, now what every developer loves to do, to write documentation, yeah. So for documentation, you'll mostly use Swagger. Swagger is not just for that. It's actually an API framework. You can do a lot of things with him. Recently, I think a year ago, the company that produced Swagger gave it to open source to be foundation for Open API Specification 3.0. So that's currently standard. You'll find that it's called Swagger still, but yeah, it's now new name is Open API Specification 3.0. So it's an API framework. You can use it to generate documentation for your APIs. You can actually define your APIs with it and then generate it. You can automate API testing. There are a lot of scenarios where you can use Swagger for. So we'll see how it's integrated into ASPNET Core later. Okay, so another new thing are API analyzers. They are coming with 2.2 and Swagger support. We had some new things in 2.1 and some are new in 2.2. API analyzers I spoke about earlier. Those are Roslyn things that just check whether your APIs conform to some conventions. For Swagger, to actually add it to your ASP.NET Core APIs, you'll use either Swashbuckler and Swag. Those are two most popular NuGet packages. And you'll use Swagger UI to just display the documentation for your API. Okay, so you implemented everything, you released your API, and now you can rest. Everything is rainbows and unicorns, yeah? So you know that's not the case. When you do actual deployments, problem starts, of course. One of the problems you might face is that some users are abusing your APIs. They are making too much requests on it and actually affecting other users. So you can add user limiting. In the demo, we have limit per token, and it's implemented with middleware. You can implement it with middleware or action filter. So per token, that means per JVT tokens. If you use the same JVT token, you cannot call your APIs more than, let's say, once in 5 seconds, which is a case in them. Or you can use this library from Stefan Prodan, ASP.NET Core rate limit. It allows you to limit per client IP or per client ID header. Next thing, versioning. So versioning libraries in .NET, like when you have NuGet packages, is pretty easy. So you just, when you need to release a new version, you just tag it like that and do a release and push it to NuGet repository. And if your client tries to use the new version and it fails, they can just roll back to the previous one. So there's no big issue there. But when you're doing with APIs and you're not implementing versioning, your APIs are immediately available to all your clients. So you have some problem, you deploy it to production, and suddenly all of your clients started failing. So you want to avoid that. So whenever you are doing some breaking change on your API, you must version it, you must upgrade it to a new version. There are several different ways you can version your APIs. So you can put a version number within a URL. You can put it in query string. You can have a custom request header, so to avoid changing URL, or accept header, or modify the existing accept header. And for that, in ASPNET Core, you'll be using this Microsoft ASPNET Core MVC versioning package, which supports all of these 4 types, and by default, it's using query string. Earlier, when I spoke about REST and RESTful, I mentioned strict and pragmatic approach. If you are strict, you won't be using URL and query string versioning. Why? Because with that, you'll have 2 different URLs pointing to the same resource. And in REST, that's a big no-no. So, okay, we'll see a demo of this later. And at the end, we'll probably want to implement some kind of monitoring to track how's your API behaving, how's your users behaving, your clients. That can be simple logging, so you just log some information, errors in files, database, some third-party service, something like that. You could do performance tracking, user tracking, so by let's say this rate limiting that we have mentioned before. If you are on Azure, you can use services like Azure Monitoring, the Application Insights, and Log Analytics. So they are pretty easy to set up. You just need to enable them in Azure Dashboard. 2.2, .NET Core 2.2 has this new health checks that I mentioned before, and we also have that in demo. You can use this open source project, which is called Warden. It's not really actively deployed at the moment, but it allows you to have different health checks, something like sensors that you can implement in any part of your application and then collect all the data from them at one point to have some kind of dashboard. Then you can also use some third-party monitoring services like New Relic, Stackify, Monitis, Runscope, etc. Okay, let's switch to demo. I think I talked enough. Okay, so like I mentioned before, this is available on GitHub, and there are several branches that you can follow through this presentation. So all of these slides that I had, best practices, security, testing, docs, limiting, versioning, monitoring, you can just switch the branches here and just follow the talk. Okay, so this demo application is called Board Games API. So I'm kind of crazy about board games. I'm collecting them mostly. Don't have enough time to play them, but okay. So this API is just a simple list that returns all of my games. I can do CRUD operations on them. I can modify existing games, add new ones, delete some of them, and that. Okay, and how that is done. I have data folder here. So this is database. It's actually just a plain JSON file, which is loaded and operated upon using this repository. So it has a collection of games there, and this repository looks like this. It has get methods and create, delete, and update. You'll see the first get method has paging implemented. So by default, it will return first page and page size of 10. And this is implementation of that. It's not really interested, since we have just get page, which calls get games, and then just uses subset of that. Get by ID just finds the first one which matches the ID given. Create game just saves that to the list. Delete deletes one with the ID, and update, of course, updates and saves the new version of the game with that ID. And get games just loads the resource from the assembly, and that's it. Okay. So let's take a look at startup. So startup is the main entry point of the ASP.NET Core application. It has two methods. One is configure services. Configure services, with it you define which services are necessary for dependency injection throughout the entire application. So in here I'm adding games repository as a singleton. So that means only one instance will be available throughout the lifetime of the application. Then we have add MVC and set compatibility version. So this is necessary in 2.1 and 2.2 if you want to use the new features of that specific platform. So you can use ASP.NET Core 2.2 and set the compatibility level to 2.0 if you have some problems with it. But this is by default. And another method is configure. And in configure method, you define your pipeline. So here you define middlewares that are connected and form your pipeline. And it's important in which order you add them. So when you add, let's say, this error handling middleware, it will be added before HTTPS redirection middleware and before MVC middleware. So it will have a chance to modify something and do something with requests before other middlewares do. And while we're there, let's see how this error handling middleware looks like. So this is just a basic middleware. It's just a class. It doesn't inherit from anything. It needs to have an invoke method, and invoke accepts HTTP context. And all this middleware does is just tries to call next middleware in chain. And if something happens there, some error, exception, it just logs it and handles it on some way. And handling is done here. So it sets response code, in this case internal server error. You could check which type of exception it has, and depending on the type you can just return other response codes. And then we are just creating this problem details, which is a new thing in 2.1, and it allows you to format the error according to the RFC 7807 specification. So this is a standard that they are currently using in ASP.NET Core, and it just serializes that JSON and returns it to client. Okay, and one more thing to show is actual controller. So we have API controller here. It inherits from controller. It has route defined, and then we have methods. So we have delete, post, put, and get. Delete method accepts ID, so this is routing here. By default, this is the default route, API/games. And then for delete, it will be API/games/some ID. Also for other methods. For HTTP GET, we have GET ALL. This is with paging. And we also have GET SINGLE game, which just accepts one ID and returns a single game. Also, you'll see that we are using action result of game. And in case we cannot find ID, or it doesn't exist, or something like that, we just return 404. So this is HTTP 404 status code. Also in put we have the same. So this is it. We have also logging defined in each call. So it logs something at console or debug, depending on where we defined it to do that. And yeah, also forgot about models. So we have game model. This is actually our domain entity. And this is view model or binding model or whatever, which has validation there. Also, I mentioned that API controller attribute defines some conventions. If you add that, you don't need to specify that if not model state is valid, return bad request. That is done automatically. So all the validation with the data annotation is done automatically. You don't need to specify that after you define API controller attribute on top of the controller. Okay, I think I went through all. So let's see how that is working. So when we run it in browser, Firefox gives us by default /API/games, and it gives us nicely formatted JSON response. But of course, it is hard to do that in browser, so let's use a tool for that. This is Postman. I mentioned it when I talked about the tools that you can use for manual testing. It does a lot of things. You can use it for automated testing too. It can generate some tests. You can run them using your npm tools or things like that. And it's in here I have a collection of calls, and also this collection is exported, and you have it on the GitHub, so as part of the code, so you can play with it. Okay, so we have get all games. When you call that, you'll get status HTTP OK, and you'll have 5, I believe, since size 5 is given there. So this is one page of 5 items. You can also call get game by ID by giving it the ID, and it also returns 200 OK. You can create new game. When you create games, you need to define what you're creating in the body. So this will be bound to the game input or game view model there on server side. And when you call it, it will return 201 created. So that's also by REST standard. And within that created call, it will also return location. So this is an actual URL of the resource. So whenever you return 201 created, you need to return URL to the actual resource. Then we have update game, which is doing almost the same thing. And we have delete. When you call delete the first time, it just deletes and returns 200 OK. When you call it second time, it returns not found, and it formats the response like this. So this is also added to 2.1. RFC 7807 something. Yeah. Okay. So let's switch to security. Okay, so now we have new things in startup. We have this add JVT barrier authentication. So, like I said before in presentation, we'll be using JVT tokens for authentication. And it's moved to, which is best practice, it's moved to a separate extension class, and you'll have it encapsulated here. So whatever it's needed for JVT authentication scheme, it has an issuer, so it has a definition of how to do actual token validation. And another thing that's added is this use authentication. So it's added before MVC, but after this error handling middleware. Okay, and on games controller, we now have this authorize attribute, which actually says that the client cannot call these methods unless it's authorized, it has a valid JVT token. We also have this authorized role SQL admin on all the writable methods. So when you create, delete, or update existing items, you need to be admin. You need to have JVT token which has admin role. And on get methods, you can just be authenticated with a valid JVT token and it's okay. It will give you read-only access.
A question about that?
Yeah.
Can you also do that more custom-made for your own needs?
Mm-hmm.
So implement like a override the attribute and...
Yeah, there are policies actually. There are things called policies, and you can define, instead of roles, you can define policies. Policies you can define in your startup class, and there you can set like, I don't know, if user is at least 18 and max 77 years old, then it's allowed to do that. And you just define here authorize policy equals and name of the policy, and it will use that. So that's a more granular and better approach actually than roles.
Is it also new in the core?
Yeah, new in .NET Core, yeah. Okay, what else I said earlier about this, how we generate tokens, so don't do that in production. So this is just for demo purpose. It actually accepts the name of the user, whether the user is admin or not, and who is issuer and who is the key, which key is using, and it just generates the JVT security token and serializes that to string. And it's been using for demo token, and in here I've said not for production use. When you call it with get token, and you may give it admin equals true, then you get admin token back, and when you call it without admin, you get read-only token. So you can use that for testing. Okay, so let's see how that can be done now, how it can be called from Postman. Yeah.
So with this token generator, you don't need an identity server?
I don't think so. So don't use token generation.
No, but for testing.
Yeah,
so that
yeah,
when
yeah.
you develop something,
yeah, for testing.
then you can hook up the
Yeah.
identity server.
Yes, yes. So this is just some custom thing that exists in ASPNET Core. You can just hook it up and generate tokens. Okay, so when I try now to call this, I should get 401 unauthorized. So this is now another response. I need to give actual token to it, and this is a next step, next group of calls, which also have tokens with them. So when you call it with token, you get the actual response. Postman also allows you to do this. So you can define authorization on the entire collection level or on the folder level, and you can define variables. So in here I have one variable for token and one for admin token, and then I use them to, let's say for create game, I use bearer token and I use admin token in here. So that's how we authorize it for different calls. And here in out, I just define that all of the calls in there need to use bearer token, and by default it's using this read-only token. Okay, I want to call others, so let's switch back and let's see what can we do with testing. So now we have a new project here, BoardGames API .tests, and it has integration tests and unit tests. So unit testing, MVC controllers or core controllers is pretty easy if you look at your controllers as kind of orchestrators. So just let controllers do some kind of validation of the input, and let them call other services to do actual work, and use response from that to return to client. If you have it set up like that, then unit testing of your controllers, you just basically give some input to it and check if the expected result is given. So action result of something. In this case, when I call delete without ID, it returns not found result. Also, if ID is empty, if ID does not exist, I just create this games controller, give it some dependencies, fake dependencies in this case, since we're doing unit testing, call the controller and action method on it, and see what type it returns. So only in case everything is ID does not exist, ID exists, returns OK results. So this is actually the expected path. All of the others are just testing whether it behaves correctly when input is wrong. Okay, so when I start this, everything works, so believe me. So let's see how integration testing is done. So for integration testing in ASP.NET Core, you have this NuGet package, which is called Microsoft ASP.NET Core Test Host. With it, you can just create test server, define URLs which will be used, and which settings should it use for, in this case, for authentication, authorization, and then create client from that. And in here, I just generate the two different tokens, so non-admin and admin token, and then just call, do real calls on that client, and check the response. So this actually gets the HTTP response and JSON result and stuff like that. Okay. So next thing, documentation. So we mentioned Swagger before. And in this demo, I'm using nswag, NuGet package for Swagger. And I have it here. So services add Swagger. So that just adds all the services that are necessary for Swagger support. And in here I have app use Swagger. So this adds Swagger middleware in there. And this is Swagger extension. So in here I have some settings, some default metadata for the entire application. And Swagger also is good for using the existing sources, like for instance, this one is using your XML comments. So I have added XML comments for all the models for controllers, and it just uses all of that information and generates this for you. This is Swagger UI, and the actual Swagger file. So this is Swagger. It's just a simple JSON file with all the metadata that you need, and you can use that for whatever you want, basically. And this is Swagger UI, and we have games, and it displays all the endpoints here, and you can get all games. You can even try it out. If I try to do it now, I'll get error unauthorized. It's 401 since I didn't give it the token. But I can also authorize it. Let's say I'll use this get token call that I mentioned before. I'll just copy this token and add bearer and authorize. So if I try to do it now, I should get the correct response. So not only you have the documentation for your API generated, but you also have an interactive test playground for it. So it's pretty cool. This is only one thing that nswag supports. It also supports another type of UI. I don't remember how it's called, but it has all the calls on the left side, and on the right side you have outputs and documentation for that. Okay, so that would be it. Yeah, I also mentioned API conventions. So when I get back to the games controller, we have this API convention type, default API conventions. So default API conventions is a type that exists in the ASP.NET Core 2.2. That's something that you have out of the box, and you can see how it looks like using the Sharper, of course. So this is it. So it's just a plain API class, and it defines how your action methods look like and what will they generate, actually, how they will be recognized. So if you have a method that has a get prefix and it has an ID suffix, it's get method, and it should have response codes of 200 and 404. So it actually has those conventions there, and you can just create your own static class, add some conventions expected, and just stuff it into games controller here. And if I fail to follow, let's say, for instance, I am not returning this. So this is Roslyn analyzers that are added also. For that, you need to add Microsoft ASP.NET Core MVC API analyzers NuGet package to your application, and you'll get those warnings. Okay, so one more thing that I mentioned is .NET REPL. So REPL is kind of a tool that you can use to call your API from the command line. So I'm not sure how that is functional, whether you would want that or not, but yeah, you can use that. So you can call it with .NET HTTP REPL, and you can what was that? Set base, and it should connect to your API using Swagger. So it actually uses Swagger, and it acts as a client of your API. So you can have ls, and here are all the endpoints, and you can see the API, ls, cd games. So I'm not sure if this is usable, but okay, you have it. So that's about it. They're actually thinking about making this a default when you press F5 within Visual Studio with the new API project. So there you have it. Okay, so next thing, limiting. I'll just quickly go over this. So we have a new limiting middleware. It has some dictionary in memory. This is demo, which saves the token access. So key is actual JVT token, and the value is date time with the last call of that API. And it just checks within certain time frame if user tries to, or client tries to call the same API multiple times. So I won't go through the code, but just let's try to call get all games. This is once, and when you call it again, you get HTTP status code 429, too many requests, and 5 seconds have already passed. Let's try again, and you have 2000 OK. So you need not to call the API more times within 5 seconds in this case. Yeah.
But this is code you made yourself?
Yeah.
But you also mentioned something about the package.
Yeah, there's a Stefan Prodan package for another type. You can limit by client IP address and things like that.
Okay, but this is the standard convention. This is or standard.
Well,
in
no. There is no standard around this. So this is just something that I added here as a demo. What can you do with? Yeah. Okay. So next thing, versioning. So this middleware, limiting middleware is also added to the startup class. About versioning. So we have this. And I also had to do this. So I had to switch back to the version 2.1 compatibility mode since at the current preview 2.2, it has problems since we have new routing, and the new routing doesn't work good with this versioning library. So I had to fall back to the old 2.1 routing, add versioning, and yeah, that's it. And we have versioning extensions. So this is just defines how versioning is done. So in our case, and this is also for the API Explorer that Swagger generator is using to actually generate everything. And now we have games controller with API version 1, which is now marked as deprecated. And we have 2 routes defined on it. So default route API games to work with all old clients, since we didn't have versioning before. And we have new route, v something, which works with newer clients. And we also have v2 controller, which only has this route. So you need to define v2 on it to target it.
You mentioned that you should not do that in the URL because it's not according to the REST container.
Yeah, it's not RESTful. So if you want to do strict REST, don't do that.
Do you also have an example how you do it in the request header?
Yeah, mostly request header or modifying the content header. So I don't know, GitHub, I believe, is using it in content header. So it's application/JSON, then some column, semicolon, and then version. So it's up to you. Okay, and yeah, you can now see how that looks like in Swagger. Also, I have problem with Swagger since it's preview. You should see all the versions up there, but unfortunately, it didn't recognize any methods here. So that should work in the RTM version.
How would you go about versioning the models?
Well, it depends. So basically, yeah. So basically, you're versioning your endpoints. So if you want to have, you can have different models for different endpoints for different versions. So it's not really something that's visible outside. You can just create another v2 model for if you have changes in that model, or you can use existing one if it's not changed. So.
Would you not rather than use assembly versions and then have like different assemblies?
Well, assemblies are not really necessary here. So yeah, basically, if you have separated domain assembly or something like that, yeah, maybe you can just use that. But it depends how much you change, actually. If it's just something in URL or it has different response, then just, I don't know, generate one class. Have one class different and all of the rest same. If it's not that big change. It depends, really, what you're trying to achieve. Okay. And yeah, the last thing was monitoring. So monitoring is I just added this here. So this is how you defined these health checks. So you just app use health check and you define the URL which will be used for that. And if we call that URL, you'll get healthy by default. So you can also define other health checks. You can have one, let's say, for your database to check that and to return with, I don't know, /live/db or something like that. And yeah.
But where is that code?
For this, you don't need code. This is by default.
Yes, but if you want to add checks.
You add them to a startup class. So just use this, use health checks and provide options here.
Okay.
So you decide. Whatever you want. So this one is just you can have your client or your dashboard check whether it returned status to 200 and content healthy, and that's it for this by default. Okay, that was it for the demo. So let's close this up since it took more than an hour. Okay, so we went through all this. For further information, if you want to play with it, you can check Microsoft API guidelines. You can check all these specifications, standards. You can see alternatives like GraphQL. So this old talk was for REST APIs. You can check GraphQL, which is open source alternative to REST, developed by Facebook, then given to open source. And you can see those APIs, like those are examples, and they are pretty good APIs. I used most or all of them. So let's say, for instance, GitHub version 3 of developer API for GitHub is REST, and version 4 is GraphQL. So you can compare how those two look like. Also, Nate Barbettini has this beautiful REST API samples and video course on GitHub. Be sure to check that. It's pretty awesome. And the samples for this is here, and the presentation is also included from one conference. I don't think it's this one, but yeah, this presentation is available on that address too. Okay, thank you.